So today's lesson should go kind of quickly, and then hopefully we'll be able to take some more questions on any of the other homework. Does everybody have your notes? Did everyone grab a copy of notes as you came in? Okay. Right there. So, 8-5, yep. It is Halloween. Happy Halloween.
I hate Halloween.
No, you could do it tomorrow. Yeah, okay.
I thought I had gym today.
Right.
That was pretty
What you're saying is true.
Carmen, Dave's depressed. Can you go get him his notes? The Patriots just traded a player.
They traded Jamie Collins.
Hey, you know how you wouldn't be upset? If you didn't know about it yet. Like if you weren't on your phone. So, I have zero sympathy for you.
But I'd eventually get to be sad.
So, it wouldn't be here and I wouldn't have to worry about it.
Roasted.
So, Inscribed Angles make some really cool relationships that once you wrap your head around it, makes everything a lot easier. So, we have these different theorems that we want to talk about, and they all come out of where does that angle actually start? Does it start on the edge and go across to the other edge, or does it start in the middle, or things like that? So, if we have angle B is going to be half of the arc, since angle B starts on the opposite side of the circle. So, this angle will be half the measure of this arc. That angle will be half the measure of arc AC. Likewise, we know, and this kind of justifies our theorem 86, if we inscribe a right triangle into my circle so that all 3 points are on the circle, I can end up with my hypotenuse being the diameter, which means that the arc it inscribes, it's new gym day, they're all, yeah. The arc it inscribes, how big is that arc? If it's half the circle, it's 180, which justifies why that angle is half of that arc, or 90. The measure of an angle formed by a tangent and a chord is still half the measure of that intercepted arc. So arc CB, like the major arc here, that angle, that obtuse angle, will be half of that. Arc CB, the minor arc there, or arc CDB, or BDC, going the other way, same thing. Any questions on those three rules, theorems, corollaries, whatever?
I don't understand theorem 87. Just like the way you, I don't know.
Give me a second, I gotta get out of your test back. You don't understand 87. So, the measure of this arc. So how, excuse me, how much of the circle? So if it was 180, it'd stop right there. So let's say that's probably like, I don't know, 230. But I'm going to say for that arc measure. But of course, I can't have this angle be 230 because then that would actually be larger than obtuse. It would like go around past the straight line area. So this angle right here, the obtuse angle, will be half that arc. Or if it's a small arc, like a minor arc, still this angle right here is half the minor arc BDC.
Okay.
Cool? Then, when we start to have like multiple lines or quadrilaterals or weird like intercepting objects, two inscribed angles that inscribe the same arc are going to be congruent. So this arc right here applies to angle A and angle B. So even though they have different lengths, they have the same angle measures. Angle A and angle B, because their points and the arc that they make are the same. Any questions on that? That's where people start to get screwed up because it looks weird. This line being so short and that being longer and then these being almost equal to each other, it plays tricks on you. But they are congruent.
Wait, can you repeat that?
So, two inscribed angles. So an angle where all 3 points of it are on the circle needs to be inscribed. Two inscribed angles that intercept the same arc. So let's call this ABCD. So we're going to call minor arc CD is, let's say, I don't know, how many degrees would you think? Like 110, 120, something like that? Just say it's a 120 degree arc. Angle A intercepts that arc, so we know angle A is going to be half that 120, or about 60, if that was 120. Angle B intercepts the same arc, so it also is going to be 60
Would that
degrees.
apply to theorem 86, or would this not?
What do you mean?
So, like, you know how it
I was
says.
looking at that weird. Thank you.
Oh, okay.
They're all
I was-
corollaries. They're all like the same
Oh,
related theorem.
I was looking at that like it was like.
Yeah, I looked at it as like as a separate thing.
No, which helps us because then we can connect and make triangles and do all sorts of fun
Yeah, I
things.
was looking at it like.
Well, except for the bottom.
And thank you.
Then the opposite angles of a quadrilateral inscribed in a circle are supplementary, which just makes sense because if you connect like A to C and you look at angle B, or there, getting tripped up. If you look at angle D inscribes the arc or intercepts the arc ABC. So we know it's going to be half of that arc. Angle B intercepts the angle or the arc ADC, and it's going to be half of that. Well, the whole circle would be 360 degrees. Half that, 180. These two are going to have to add up to be 180. So no matter what, opposite angles of an inscribed quadrilateral. So all 4 points have to be on the circle, but they're going to be supplementary. Any other questions?
Wait, okay, so like the points themselves have to be on the.
On the circle, yeah, like on the edge. And there's all kinds, like if you want to start to like dissect and break this apart, there's all kinds of proofs that we could write of relating, congruent lines that go across and radii and making triangles and the congruent angles from vertical angles and supplement. Like there's a whole slew of proofs that we could do here. But as long as we accept this because of what we know, then we're good to be able to use it. So problem done out for you to see here just as example. So if I have this image and I'm looking for A and B. So if I know that my inscribed arc my angle PQT, so we're looking PQT right here, is going to be half of that arc. Then I know that the angle is 60. And by the way, this 120 is something that we derived. I just have it here because of when I took the screenshot. Likewise, if I then know that arc and I'm looking for the value of B, then I can kind of work backwards and say, oh, I know that's going to be 1/2 of the sum of those two arcs. Since angle B goes to point S and point P, I can't just use the 120 since that stops right there, so I have to do the 120 plus the 30. I know it's going to be half that or 75.
Okay, I was confused on why there was like, you can't really see it.
Yeah, the colors don't. We've talked. Actually, we were just talking on Friday about getting access to color copying, and like right now we can't make color copies, unless like we just do it here.
That's
Yeah.
expensive.
Wait, how did you get the 120? Did you get like by 60?
Yeah. So this 60 would have been given, and because I know that PQT are all on the circle, then I know that the arc of PT is going to be twice that of the inscribed angle. And then we use the backwards, trying to solve the angle. I know it's half of the arc. The arc's double the angle, or the angle's half the arc.
So it was 30 a given in this triangle?
Yes.
When I say triangle, sorry, the circle?
Circle, yeah, 30 would have been a given point.
Just because you had to find that, I was like, how did you find that?
Yeah, I should have taken this picture at a different time. But as we solve a few of these, this will make a lot more sense.
Alright.
Now, if circle O has triangle, or actually, I guess, well, obviously you can see it's a triangle, but we don't really care that it's a triangle. How do we figure out the measure of angle A? This just ties back to one of our theorems. Caleb?
You would have to know the arc of two little dealy points.
Yeah, how do I know the arc then?
Well, you know it's at 180 because since the line's straight, you can assume it's a diameter.
It is a diameter since it goes through the center.
Well,
So our work for that would be measure of angle A will be half of that arc of 180,
90 degrees.
and that will equal 90. Who's going trick-or-treating tonight?
Oh yeah.
going
I'm passing
with
out
my
candy.
brothers.
I made the joke that I'm going to dress up as a teacher and grade papers on my front porch.
You should-
But I'm not joking. I have a stack of papers to grade. So
So you'll just be sitting on your front porch grading papers.
probably.
That sounds
Sobbing as your
bad.
hand up candy.
Is that what you do for fun?
What, grade papers?
Yeah.
Yeah, but normally I sit on my back porch.
Oh.
If it's nice enough to sit outside. If I had to sit inside, I'd probably light a fire
Do you
if it's cold
enjoy
outside.
it?
I mean, I enjoy providing you guys feedback to help your learning process.
That's not. I actually enjoy it.
One way to put it.
So, deriving angle 1 here. Obviously, we could solve it the same exact way that we just did, knowing that the arc it uses is 180. But let's have a little bit more fun than that. Let's look at angles 1, 2, 3, and 4. Because it's too easy if we just look at angle 1. So, angle 1, how do I know what angle 1 is? Not Caleb.
Oh, come on, man.
Lynn?
There's a diameter there, which means that angle would be 90.
Yeah, so really the rule that we could create here was if an inscribed angle intersects the diameter, it's got to be 90 degrees. So we know angle 1 is 90 degrees. What arc? I'll make this more fun. What arc do we use for angle 3?
Please.
Carmen?
It's the supplement to 70.
The supplement to 70, or this arc right here that is 110, angle 3 would have to be half that 110, and it would be 55 degrees. Now, whether I use my angle of 70 degree, or sorry, my arc of 70, or use the triangle angle sum theorem, huh?
I was gonna do that.
Yeah,
was gonna
I
solve
knew
for
you
2.
were.
I was gonna solve for 2 and then just have 3 be
So
numbers.
that can let us check, right? So if I can compare my triangle angle sum to my arc measure, they should line up and give me the same answer of 35 degrees. And then angle 4, not part of my triangle. David?
Wouldn't it be we used a 40-degree arc?
So how big is it?
20 degrees.
Yeah. Now be careful, because up until today, we mainly dealt with angles that were coming out of the center point. What if I created an angle 5, and you can see kind of the reference that I'm going to make. Sorry, not degrees. What if, well, I guess it could be degrees. What if I made an angle 5 right there? Because then, what if I made an angle 6? Because if we forget any of this, look at what we remember. So using the rules that we have today, how could I find angle 6? Well, that's still a center angle. What about angles from the center? I mean, I could use triangle angle sum here and kind of work this a couple different ways, because I know that if this angle, actually, I want to see if we can derive this. I'm curious if you guys can connect the dots. So we just solved angle 4, and I'll make that black. It's right here, right? What if I don't let you? Well, I'm curious what direction you're going, Ethan.
Would you use your 40-degree arc?
For this angle or for angle 5?
Angle 5.
Yeah, what is angle 5?
40 degrees.
Yeah, because when it's from the center, it's exactly the same. But what if we didn't know that? So let's work through how some of these rules get made. What if I call this angle 4, that's on the inside? Let's call that angle 6. What about angle 4 and angle 6?
Oh.
Caleb, because other hands keep going down.
I think. Okay. Well, I know 4 and 6 are the same. They're the same measurement.
Why?
Because they're a chord, and if you do since you have two radii, well, I guess you have two radii going out, and they're connected to.
So we've made
An isosceles.
We've made an isosceles triangle because we drew the radii. So this angle 6 also has to be 20 degrees. So if I've got 20 and 20, then what's left over is 140, which is also the measure of that arc.
I have a question.
So that can back up my justification that when an angle from the center intercepts an arc, it is equal to the arc. When an angle from the edge intercepts an arc, it is half of that. And we could build all of these proofs out of one circle. Okay.
No.
Any other questions? We went way further than we needed to on this, but it's just to kind of see those connections and see that whole idea of like, all we really have to do is draw one thing and the snowball starts rolling and we can do a whole lot.
Calvin would have loved that problem.
How did you figure that out without finding angle 5? Because, like...
Because we, as soon as we drew this, had an isosceles triangle.
Oh,
So without using the arcs, like the only arc we used was this 40 to say that this was 20, and then this had to be 20, and then
Okay.
the center angle is just your leftover.
Yeah.
Or you could also say that if I know that that's 20, and then this has to be supplementary to
That's
that,
what I
and
understand. Okay.
yeah, we could do a lot of different ways. So what would be the measure of angle 2? Scarlett, what do you think? What would be the measure of angle 2? Especially if you use highlighters. Here's my advice. When you look at the problem and you look at what you're given, trace out where that corresponds to. And then if you're struggling in a different color, look at what you're looking for and trace out where that goes.
That would also be pretty good, right?
Why?
I don't know. It just kind of looks right. But when you put the colors up, it made it easier. I don't know.
When you put, so if I could quote you, I'm just going to put that quote on the wall. When you put the colors up, it made it easier. Literally might laminate. But why? Like, what do the colors have in common?
They're the same, like, shape. They're just kind of
Yeah. Yellow goes to here, and yellow goes to there. Green goes to there, and green goes to there. They're intercepting the same arc. So then, what if I asked you what the arc measure was? Michelle?
76.
76, because it would be twice that angle. Be careful with those. I found it on the cart tipped sideways, and it had leaked all over the cart, so I cleaned it up. But yeah, it's fine. But just be careful if you like take it home or anything. Don't let it tip sideways. Oh well, thanks. Yeah, just so you guys know, we were really worried that we weren't gonna have fog machines, and we knew you guys wanted them, so we just each bought a fog machine, like for ours, not school money, but we're just like, we'll buy a fog machine.
Look how that works.
Yeah, maybe I'll set that up at my house tonight, make it all creepy.
Yes, dude.
Oh,
Do it
dude,
on your front
porch,
porch
like,
so
on-
the kids come and get your kids.
They see a weird old dude sitting on this porch. Great.
Should I like put my bow tie on?
Yes.
Actually, so I don't think you guys are
You
here.
might get arrested.
I have a penguin costume from back in the days of ST Math and Gigi the Penguin.
Oh,
So I thought about just sitting outside wearing my Gigi costume tonight. So here's the other thing.
I found out.
What if I asked you to solve every angle that you see up there? So we've solved angle 2 is 38. I'm going to capture that and then I'm going to get rid of it. There's one other chunk of information there.
Well, wait, what? Wait, what are we?
So angle 2 we're done with.
Oh, angle 2 we're done. Okay,
So I might as well label then 3, 4, 5, 6.
So wait, what do you want? Do you want me to just name?
What if it said solve everything? Solve for the triangles.
every-
Actually, what if the question asked, are those triangles similar?
Well, Okay. Well, they
yeah,
are
you could do that.
because. Well, do you want me to? She's freaking
Sure,
out.
you're talking.
Okay. So you know. Well, okay. So you know 5, and I think it says 5. Yeah, 5 and 4. Okay, are vertical angles.
Okay, 5 and 4 are gonna be equal.
And
But what
2,
are they?
Sorry.
Do
Oh,
we
you
know
want
what
the
they
actual
are?
Angle measure.
Yeah.
Well, let's think here.
Michelle, do
I think
you
so.
know?
I know.
Maybe.
Ooh, Megan knows it.
Okay.
Wait, well, I don't know. I know 6 and 3 are both 55 because since that one line is the diameter and.
Ooh, how do you know it's the diameter?
Ooh.
Weren't we solving?
I don't see a center point.
Oh.
Oh.
It's probably. We can't.
Lynn, I'm gonna work my way back around.
Are we asking if it's similar or not?
Yeah.
I think, wouldn't it be similar, if it has all 3 angles that are equivalent, wouldn't it be similar?
If all 3 angles are congruent, it's similar. We're trying to find out, is it? We're trying to answer the question, would it be?
Well, yeah, it is similar.
We have to prove
Well,
why.
because, okay, so you have the 2 lines that like make an X, which
Okay.
makes those 2 math terms. Well, math terms are tough.
They intersect. That's
They
fine.
intersect.
It's good.
Yeah.
They do make an X. I
And then
agree.
you know that 2 and 38.
So we already know a pair of congruent angles.
And then if you get the other pair, and then there's just one pair they have to make.
So okay, if
these.
4 and 5 are congruent, then the leftover angles have to be congruent. But I still think that maybe Emma has seen what we're all missing.
Sorry.
Hopefully.
That's okay. Is it angle 435 because it's half of 70?
So those have to be 35 degrees. Now wait though. Wait. Are you sure?
Yeah.
Yeah. Yes. Yes, she is.
Yeah.
That rule.
Over
Ooh, Max is making a face.
You don't know that proves the center of the circle.
And if it was the center, this wouldn't be 35, it'd be 70. You gotta be really careful. So here's how we could do this. Megan, do you know?
Are you asking us to find the angle measures or find why they're similar?
We need to find the angle measures. We can work our way to saying that they're similar without knowing the angle measures, because we have these would have to be equal to each other. And then the leftover angles would have to be equal to each other by triangle angle sum theorem. But how could we solve my other unknowns? Because you're gonna face problems on your homework where like you don't use rules that don't apply. If we try to say that 4 and 5 are 35, that is breaking a rule, because first off, that only works if it's on the edge. This vertex is not on the circle. And if it was the center, it'd be equal, but it's not the center. So crapola.
My mom's.
Caleb's waving around
So,
again.
I think you could know what angle 6 is because you see. Well, you said it's not a diameter. I don't think it needs to be a diameter. If it's just cutting straight through the circle, if it's a straight line through the circle, you know the half it creates is 180, and since you know,
But we don't know it's the diameter.
does it need to be the
That's what
diameter?
I was
To cut it in half, it would be.
Oh, that's
So
not
we can't
the
just assume a
diameter.
straight
But
line.
that's what I'm telling him. It's not the diameter. Or at least we don't know that. Let's write down everything we know. Carmen.
Okay,
That would
so, okay, so it's a chord. So if, wait, okay, I was going somewhere with this, I know. Alright, so if 38, wait, can I come into the board for
Sure.
a second? So, if,
I really, by the way, the reason I'm wanting us to struggle through this together is I think it will make your homework worlds easier. After we see the whole, like, how much we can do, you just don't realize it yet. Go ahead.
okay, so this chord right here, or not this arc right here, would have to be 72, right?
6.
Or that. Wait, what?
You were close. You were 76.
That's 30.
Yeah, I knew that.
The number of trombones that led the big parade.
Yeah. Yeah. Okay.
Do you not know that song?
No.
76 trombones led the big parade and 110 cornets. It's from a music. It's from the Music Man, like one of the most famous.
I don't like
You all
musicals.
disappoint
Is
me.
that
We're
like
not
You
old.
disappoint me too.
I don't like musicals.
All right, it's going on the list that I have to show you guys. Okay, sorry, continue.
Okay, so and then where was I going with this? Oh wait, okay. And this is a chord right here, and then there was something about some angle thing, but don't exactly remember. Let's see what I'm good, but I was going somewhere with this, I promise. Yeah, I don't know. Okay, just kidding. Never mind.
Let's come back to this in a minute. I'm gonna let that percolate. Let's get through the rest of the notes and we're gonna come back to this.
I used to like it, now I
I
hate
used
it.
to.
Everyone says
All right, let's get through the rest of the notes. I don't want to take too long on that one. In the diagram at the right, what is the measure of each numbered angle? So now we have our quadrilateral. We have angles that are all inscribed on the circle, so they're on the edge of your circle. Our same rules still apply, and we have a diameter dotted across our circle there. What's the first thing that we could figure out, Mr. Stravler?
The first thing that we could figure out, wouldn't it be the angle 4?
Okay, how so?
Because you could like, wait, let me think about this.
There's multiple right answers here. All depends on your brain, how you look at it.
Alright, let me think about this quickly. Wouldn't the 80-degree arc and the 60-degree arc form a 140-degree arc? And then you could find angle 4 because wouldn't it be like half of that? And so that'd be 70 degrees.
Yeah, I agree with that reasoning. Emma?
So then
So write it down, bro.
Yeah.
the rest of the circle would be 220, right?
Yeah, so then the,
Find angles.
not complement or supplement, but like the sum that gets us to 360. So the rest of my circle,
We assume that line going straight through is the diameter.
It is.
well, does it go through the center?
Okay. I didn't want to make
Yeah,
any
yeah.
assumptions.
And I already said we have a diameter dotted across the circle. Like
Okay.
I said that. So,
Make sure.
Michelle,
Okay, so there was a whatchamacallit on the back thing that said,
A theorem.
It was theorem 86, one of them, and it said, that, the alternate angles in a quadrilateral equal 180 when,
opposite angles. Be
opposite.
careful.
the potato tomato, and then, so, 4 and 2 together are supplementary, which means that 2 has to be, 110.
So 4 and 2 have to be supplementary with each other. So since I already know that 4 is 70, then angle 2 has to be 110, which is also justified by this arc measure being 220. But where I was trying to get you guys to get to also, when we see the diameter, we immediately see the right angle.
Me.
Me. Okay. So if there's a little dot in the center with a line going through that, can we assume it's the diameter?
If there's a dot in your circle,
And
it's
the
the
line
center.
goes through it, we can assume that is the diameter.
Yeah.
Okay.
Doesn't matter.
Any other questions on that one? And then if we wanted to, what if I asked you to solve for this arc?
Wait.
That would be a number.
Do I have an angle that intercepts that arc?
Yes.
Carmen, your hand was slowly drifting up.
Like, is it? Yeah, I'm pretty sure that. Does the diameter bisect angle 2?
What do you think?
I mean, it kind of looks like it does.
But you
Cause
can't judge based on the looks of the picture.
I know, but
No, it doesn't.
Michelle?
Okay, so can I come up?
Yeah.
So,
I'm just gonna draw
Yeah,
that
that's
solid.
what I was gonna draw.
Oh, I just wanted it solid instead of dotted.
Okay. Well, this is like the thingy, so this would be, this angle is 30 because it's half of the arc, and then this angle would be 40, and then you could figure out triangle angle sum.
So I
figure out-
love what you're doing, Michelle, but you're not really writing in a way that people can see and make sense.
That is.
So I'm watching your classmates' eyes as you're describing. I understand what you're saying, right? But this doesn't. This is kind of a jumbled. So let's
Yeah.
drag some of this out and let's
The
clean this up.
calibration is really weird.
All right, hold on. So talk me through and let me write because I know the calibration's weird. So this angle, you
it
just
has to be
said.
half of the arc because it's at the other end, so that would be 30. And then same goes for the other side of the angle, like 4 things.
So this is where I was about to check. Does the diameter bisect? Because this is a rule, like this is something that we want to be aware of. This angle relates to this arc, which makes this 40, not 30. Does the diameter bisect? No. So then, by triangle angle sum theorem, I can figure out then that this other angle would have to be
That 110.
like this one right here.
Oh, that one would have
70.
to be 50.
If that's 90 and that's 40, thank you. This has to be 50, which would make my green arc right here 100. It's on the edge. Make sure we pay attention to that. And then the arc up here would be, we already knew the total arc out here, right?
Yeah.
This total arc was 220. So this arc will now be 120. And then the 60 and then the 80. 120 plus 60 gives me 180. The top half of my arc. I could have also just used the diameter.
You could have also just used the diameter, Mr. Hudson.
Yeah.
If I have a diameter drawn. I was hoping somebody would get to that point. And based off Max's smirk, I can't tell if he did or not. But if this diameter is drawn, I know that this arc is 180. And if I know part of it, I can solve the rest
I
of
should
it.
have used.
Read your book. Quit learning math.
Savage.
I really actually just want them to be able to like come join class if they're interested. But no, it's independent reading. Do you guys get like we did all this work, but really we could have just said, hey, this arc has to be 180 because it's from the diameter. And then we could have found our 120 and our 100 based off that. But there's a lot of right ways to get to Florida.
Okay.
So, many ways we can solve these problems. How much for?
Oh wait, Mr. Hudson, are you recording this?
Yes.
Okay.
Oh, sweet.
Hi, Brian.
Hi, Brian.
Hi, Brian.
Don't die.
Yeah, please come back to us
Wait, where is he?
He wasn't gonna come back to school.
until after math class, probably.
No, at
he
all.
just isn't going to come.
Well, whatever. All right, we need to wrap up. In the diagram,
Brian, if you don't come back, Luke will be very happy.
in the diagram,
Missed that ball.
in the diagram, SR is a tangent. If PMQ is 212, what is PQR? So let's label what we have. PMQ is 212. I'm going to zoom back in. PMQ, this arc, I'm going to color code, is 212. What is PQR? Now, what do we know about the angle formed between a tangent line and a chord?
Is it right?
From a radius and the tangent line. Flip back to the front. Check what we had.
Oh, it's 1/2
the arc.
The whatchamadoo-dad actually.
So, if I know that my whatchamadoodad is 212, my arc, then this angle is going to end up half of that. Because guys, think about it. My red angle plus my blue angle have to add up to what?
180.
And my entire circle has to have how many degree measure? 360. So it makes sense that when we have a supplementary linear relationship, we have the same sort of relationship on my arc measures. So this arc measure here for my blue portion is going to be how much?
74.
70. Ooh, not 74. It's got to add up to 360. You're not listening to what I'm asking. If PMQ is 212, not the angle, the arc, because that angle couldn't be 212. That's impossible. So that angle, if we're going to notate that, is then 106, right? It's half of it.
Ooh,
Yes.
I got it. 148.
So then we could figure out what the blue angle is going to be. What's the blue angle?
74.
That's 74, which makes the arc measure 148.
So wait, to solve for the blue angle, you
I
didn't
was
even
talking
really
about
have
the
to
blue
solve
angle.
for
I
the
was
red
talking
angle.
about the arc.
You could have just solved for the other arc because you know they have to add
Could have.
360.
Yeah.
So, or you could have just solved for the red angle and then just done
Yep.
supplementary. And
Yep.
Have to solve for that. Okay.
Yep, multiple ways.
Okay.
Whichever way you decide you like best.
Okay.
This is when math kind of is like better but harder because like I can choose my route, but I have to choose my route. You know, like it's kind of like choices can make things easier, they can make things harder. So it's all up to you to decide which route you think is the most effective. Because honestly, that like people have asked, well, what's the best way to do this? There is no best way. It's just whatever makes sense to you. So now we put all of this together. And KJ is a tangent here. We know that angle Q is 35. We've got a couple other angles labeled. What's the first thing, Max, that you would point out here, or that you would notate if you were trying to solve this?
Excuse the interruption. Could I have Jeremiah home to the office?
Is there any sort of like easy jump out at you sort of information? QJL is a right angle because QL is our diameter. As soon as you see a diameter, check to see if there's any right angles you can notate. Now that I know that right angle, Lynn, you're already calculating. Where do we go from there?
Oh, I just wanted to add in some information.
Okay. Yeah.
So, the arch for JL is 70, which means the arch for QJ is 110.
QJ.
Which means that angle K
So
would
this.
be 55.
So what Lynn's saying is this would be 110 because we can derive that this is 70, and these have to be supplementary arcs because the diameter. So whichever way we take, you then found out that, sorry,
K should be 55.
down here K should be,
Yeah.
that's outside the circle.
Oh,
That's,
does that mean it's different?
so the only way that the arc measure like comes into play is when it's the inscribed angle. To be inscribed, it has to be on the circle. So you're on the right track, except you're thinking of angle QLJ
Oh, okay.
because it comes up to here and comes over to here. It uses that arc of 110. So Y is 55 degrees, which we also could have figured out with triangle angle sum theorem. So that verifies what we've done. Then angle X though.
I know how to get
And it actually uses information that Lynn just gave us. Straddler, is that a hand or no?
Oh no, it is.
Okay. Michelle?
Okay, so our QJL is 180 because it's using the image.
Yeah, so QJL. All these are wrong. So this entire arc has to be 180.
Yeah.
Then-
the other arc, the other side is also 180.
Right.
So that would the tangent line with the QJ is it's along the arc QOJ I think or QLJ. Wait.
Are you talking about this arc?
No, going on the way to.
So look at what X. Ooh. Look at what X uses.
Because if you do like.
Because we got to get you guys out of here, so I might just take over real quick. Carmen, one last thing, and then
Wait,
I'm.
is it okay? So the arc JL, like the one like that goes around by X, like there's not another point. That one.
This arc.
That arc is 70 degrees.
Right, which Lynn gave us.
Yeah, but then X is or what? Wait, can you use that? Yeah.
Yeah,
X
because-
is the points, and so then X is 35 degrees.
Yeah, X uses this line and our tangent line, so it's the arc inside of that, which it is arc JL, and since that arc is 70, then X would have to also be 35 degrees.
I took like the big arc of like JLQ, and then I did like half of that is like X and the 90 degree, and then I minus the 90 degree, and I got it.
Okay.
What's 35? I mean, it works. How'd you get the? I saw
The theorem from the front where it says that we have the angle measure is going to be half that of the inscribed arc. So if it's acute, then our arc is kind of made from the vertex and the intersection. If it's obtuse, see, but it's still made from the arc and the intersection. So this, and it's really small in this one, but this right here, like this arc right there, we know is 70 because of this 35. So because that arc is 70, we know the angle in there has to be half that. You're welcome.
Mr. Hudson, I have some questions on your school.
Yeah, we're gonna do another question day. That or I'm just gonna make some videos.
Okay.
So I was just waiting to get some more questions and do a couple more lessons
I
and see
just
what
didn't know
else.
if you saw it.
No, I did. I was really waiting to see what else we struggle with. To see, like, do we need a whole day? Yeah. So thank you for continue to post as you hit problems. Continue to post on there.
Is there 7 lessons in this?
Are there what?
Is there 7 lessons? Or is there like more?